lesson, we're going to be treating Docker. So this class will be an introduction to what Docker is. At the end of this class, you should have a basic knowledge of Docker. You should be able to create an image and also deploy a container. Now, Docker, what exactly is Docker? Docker is an open source project that automates the deployment of applications inside containers by providing an additional layer of abstraction and automation for OS virtualization on Linux. So what Docker does to automate our own deployment of software application. So before now, when you want to deploy an application, if I'm building an application in system A, that's the development system environment, what we do is that we want to deploy the application, we install all the necessary libraries, all the necessary environments, all the necessary software that is needed for the application to run on our production server. So what Docker have done to do is to automate that process. The byproduct of deploying an image for Docker, they do not have high overhead, and so they are lightweight. So they are more efficient. Hence, they enable more efficient using of underlying system and resources. So why do we use Docker? Well, for consistency. So this ensures that the environments within the development framework is same even in the production framework. So it ensures that application runs the same way in every environment, whether deployment, whether in production. So it also isolates the containers from the host machine itself, which helps to improve security and reduce conflict. So we have portability, we have efficiency, and then we'll talk about scalability. We will see this in our upcoming slide when we demonstrate a practical project on using Docker for deploying an application. So as to compare virtual machine and Docker, you can see that for the virtual machine, which is our right hand, we have a guest machine, which is installed on the virtual machine. For that of Docker, you see that it uses the operating system of the underlying of the host machine and also the infrastructure. So that basically informs why the container is lightweight as to compare to a virtual machine. Now, let's look at Docker architecture. So Docker uses a client-server kind of architecture. So you have the client side where you as a user communicate here, and then you have the server side. So the server side is what we call the Docker daemon. So what it does is a background running process that manages all the building, running, and distribution of containers and managing of images within the Docker environment. Now you communicate with the client side via a command. You communicate with this daemon via a command line tool, and that's what we call the Docker client. So in Docker registries, these are repositories that stores your images. So you want to ship your application from server A to server B. That can be shipped via a Docker image. And so in a real scenario, you store that image in a repository, and then you can pull that image from your production environment and then deploy it as container. So don't forget, we'll look at that, but containers are one instance of an image. So we're also going to look at Docker objects, which has to do with images, containers, network volumes, plugins, and many other objects, which we will cover in our upcoming subsequent slide. So just to lay more emphasis on Diamond and Docker Diamond Docker clients, I will take us somewhere. So I have Docker installed in my machine currently. So if I do Docker -- version, this will show me the version of Docker installed in my machine. Now, so I'm able to interact with Docker via a command line tool. So this command line tool serves as the Docker client where I can interact with my Docker daemon. So as soon as I enter this command, like I said, the Docker is a client server architecture. So as soon as I enter this command, this query is sent to my Docker daemon to process and return back output. I can see. So this is used to just list your container images. We're going to see more of these commands as we move forward. But so Docker uses a server client architecture where you as a user interact with a Docker daemon via a Docker client, a command line tool called the Docker client, right? This explains the architecture. You can see we have the Docker client where you can actually input your Docker commands, and then you have the Docker diamond which processes the command and return back via the API back to the client. We have the Docker registry that houses images, right? So you pull those images can be pulled down to your get the Docker diamond. You give an instruction to pull the image. For example, you can see this is Docker pull. You are giving Docker an instruction, Docker diamond instruction to pull the image from the repository. That image is pulled, and then you can run that image, and running instance of the image becomes a container. We're going to see that really. So what then is a Docker image and what then is a Docker container? So a Docker image is just a read-only template containing a set of instructions for creating a container. So you create a container, Docker container from a Docker image. The image is just a read-only template that contains instructions of how those containers should be created. So it provides a convenient way to package your application to a configured server environment which can be used for own private use or share public with the public user, Docker user. So in Docker image, the abstract Docker image abstract is a read-only template that abstracts all the environment needed for application to work together with your application, and then it's packaged. So that package is what we call the Docker image. And so let's look at I'm using Windows system. So for you to use Docker on any system, on any environment, on any server, you need to have Docker installed. Now because I'm going to be using Windows, so I'll go through instructions on Windows, but this follows similar process. For Linux, you just have to install Docker. So for Windows, what you need to do is to download the Docker desktop for Windows installer, and then run through the installation process by double clicking on the installer, and then that is installed automatically in your system. So let's see what we're talking about. So you look at my screen. You go to your Chrome or your popular Chrome. I use Google. Click type download Docker for Windows. So I can see this is the first link. Open here. Open it, and then you can see it here. You can see for different. So for Windows 86 is for this on Microsoft Store. So click on this to download the installer. Right? You can see the installer has been downloaded. Now, as soon as you run the installer, open your command line tool to be sure that Docker is installed on your system. All you need is to do docker -- version. To show you the version of the Docker installed in my own, I have 28.1.1. So, and this is Docker desktop. You can see this is how it looks like. So you can search. Once you install it, you can search for Docker desktop and then run the application. It opens on your system like this. You can see these are showing the current containers currently on my on this host machine, which is my machine. These are images currently. We have containers, we have volumes, which we'll talk about. So once you open this Docker desktop, you can see you have Docker currently running on your system. And so to actually confirm that you do Docker -- version. So you don't have it installed on your system, just follow through the process, double click on the installation file and then install it on your how then do you anatomy of images, how then do you create a Docker image? But before then, let us look at a sample container registry. The hub.docker, this the container registry owned by Docker itself. And so you can see you can search for images. We have a lot of official images. We'll talk about the different type of images in our upcoming slides. But we have various images which have been created. Over 100,000 images have been created, and it's domiciled in Docker Hub, which is a container registry. So let's look at it. Let's say the Nginx. Of course, you know Nginx is a web server. So if you start from Nginx, you can see this Nginx official image, right? So it is being written and built. It is being written and upload on Docker by Docker, on Docker Hub by Docker itself. So it's official image. This image is an official image, meaning that it's owned by Docker itself. So if I go into this Nginx, you can see this Nginx official image. It shows us the different tags, which is invariably versions of various Nginx, right? So you can see you can read instructions of how to pull that image to your server, and a lot you can read through it on your own and go through it. But let's just return back to our. Now, how are these images created? I want to run an application on my server on my machine. I need an image for me to run a container, and that container is actually my application. So how do we create this image? Now there are two methods. We have the interactive method and we have the Docker file. We are going to start with the interactive method. So interactive method and Docker file. So for that Docker file, you have a set of plain text instructions on how those images and specification of how those images should be created. For interactive, you are running the container via an existing Docker image. So the general syntax for Docker is Docker. For images is Docker image, then command, and then options. For containers is Docker container, and then command and options. In my command line tool, remember that we say the general syntax for whether I are dealing with images or Docker or container is Docker. For images is image, and then we say the command. What command do you want to give to the image, and then options. That's general syntax. So in this case, we want to pull this Nginx image, from Docker Hub, from official Docker Hub. Remember that this Nginx an image already that have been built by Docker. It contains a set of instructions on the deployment of Nginx or on the deployment of Nginx. So on creating of Nginx containers. And Nginx, remember, is a web server. For those of you familiar with Nginx, it's a web server. It's a very popular web server. So if I do Docker image ls, it's going to list. You can see this Docker image. The command is ls. So it's used to list the images currently you have on your host machine or local system. You can see I have these 3 images on my system. I already have Nginx on my system, so you can see Nginx. So let me remove Nginx. Let me delete this image. So Docker rm is for delete. So it's Docker image, right? The command is rm. I want to delete this image, which is what? Nginx. So it's either you use you say unable to remove response from diamond config. So it's a response from the diamond, which is the server. Unable to remove repository reference Nginx container is used by a reference image, which is this. You see, so this image is using it. So I need to delete it first before I delete Nginx, right? So let's do that. So I will delete this image first. I can use the image ID or the image name. No, this is the image name and this is the image ID. So I'm going to delete this image first. Right? So I'm able to delete this. The image is being used by a stock container. So the container is using that image. So let us see container ls. So container ls, I want to see this container ls is used to list containers currently on the image. Currently on the system. Remember that we said that it is Docker container command and the option. Option that A is used to list stocked images. You can see these are stocked images. So I can do Docker container prompt. So this is used to delete unused images, containers. So if I do Docker ls, so let's even delete this image. So it's Docker container rm, that's the command, and then we want to delete this image. Okay. In order to waste time, you can use -f, which is the option to force the delete of an image, right? -f, I'll force it. So if I do Docker image ls, I have this. I want to delete this image, which is Nginx. And the reason I want to delete it is that I want to start afresh. So I will delete it. I can force the deletion. So currently, if I do Docker container Docker image ls, you can see I have just this image currently on my machine. Now we need an image to create a container. So I want to pull this Nginx image from the Docker official repository, which is Docker Hub, right? So what do? I'll do Docker image. It's an image I want to do. Then it's an image command. So the command is what? Pull. Now Docker image pull will pull the image. Docker image pull will pull the image from Docker Hub. Now you can specify the tag, which in under we say the version of Nginx you want to pull. You can swap the version 1.this. Now the latest is referring to the latest version of Nginx image available on the Docker Hub. Now this is optional. If you don't specify the version, it's going to pull the latest version of Nginx, the latest tag. If I do this, I'm going to have Nginx pull to my system. You can see. So if I do Docker image ls, you can see I have an Nginx on my system currently. So we have the image. Now the image is just sitting inside us doing nothing. We can when we run this image, the running instance of the image becomes a container. So if I do Docker container correctly, ls, you can see that Docker container ls. You can see currently there is no container running on my system. Now let's go back to our slide and see. So we want to create a container from this image we have pulled using an interactive method. So let's go back to our slide and see what it is. So now to run an image, all you need to do is Docker. This is a shortcut. You have to have Docker container run. Right? So it's Docker container run. So to run an image, use Docker container run. Now you have options. Options include IT, means to run interactive mode. So the Docker container run, then you have options. Options include -t, -p. -p is the port. So you want to map the port on the host machine to the port on the container. Now if you run the Docker container in the system, to access that Docker container from your host machine, you need to do what we call port mapping. Right? So what is port mapping? To access the Docker container from outside the world, you have to map the port on the host. That's on your laptop, currently on my laptop, to a port on the container. So when a request comes through that port on the host machine, it's directed to that port mapped on the container. Right? And so you do that an option called instance for ports. Right? You can now run Docker in a interactive mode. So let's see what we're talking about. Now I want to run this container using interactive method. Now if I go to my command line prompt, if I do Docker container currently, ls, you can see that there's no container currently on my system. If I do Docker image ls, you can see I have an Nginx which have been pulled already from Docker Hub into my local machine. Now, to run this image, to run a container from this image, all you need to do Docker container run. In shortcut, some may not add the container, but Docker container run. And I want to run it in an interactive mode or at the background. So you can see Docker container. And what's the name of the image you want to run? Is this particular image is what? Nginx. So the command is Docker container run. So you have options -t, you have -p, which is used to map the host machine, the port on the host machine to a port on the container. By default, Nginx runs a web server, so it runs on port 80. I want to map port 8080. You know, -p is a query that defines the ports you want to map from the host machine to your port on your container. So remember that Nginx is server, so it runs on port 80. So I want to map 8080 to port 80 on my container. And I want to on what? And the image I want to run is what? Nginx. As soon as you do this, you can see the container is created and it's created for the image. If I do Docker container ls, you can see Nginx. You can see the name is Nginx, and then we have a port which is mapped 8080. So port 8080 is mapped to port 80 on the container. And if I return back to my browser and localhost on port 8080, you can see Nginx. So this is coming. So when you go to port 80, when the user goes to port 8080, that request is routed to port 80 on the container on my machine. So you can see this Nginx is deployed as a container. Now, so you can see Docker gave my Nginx a default name, which is competitive this or whatever. That's because when I was running the container, I never gave the options for name. I can, if you can give an option for name, you use what? -name. So, but I won't do that. So generally, you can see that we have succeeded in creating an Nginx container using an interactive method. First, we pull the image from Docker Hub, and then we created a container from that image. Now I'm going to remove this container. You can stop this container by saying Docker container stop, and then specify the container ID. Right? You have that container stop. So if you go and do Docker container ls, which is to these containers, you will see the container. Now to see stop container, you have to use an option dashboard A. You see the stop container, which is this container we just created now. So I want to delete this container. You do Docker container rm, and then the ID of the container you want to remove. So I want to remove this container. Let's look at the image we have. Image ls. So if I do Docker to remove the image, you do Docker image rm, and then you can use the container ID. So I want to remove a Nginx container. I'm going to force it. So if I do Docker image ls, you can see we don't have Nginx again in our system. Now, if you don't have the image and then you are pulling that image interactive, for example, look at this Docker container run -g port 80. Let's even switch. Now, if I go back to, we don't have that container again. So if you run it, you can see it keeps running, and there's no application running currently on port 8080. So if I return back to our command line, I want to run this container Nginx, but this container is not on my local machine. So what will Docker do? The Docker daemon we first of all search for this image Nginx on my local machine. If it does not find the image, it will go to Docker Hub and pull that image first, then run a container from that image. If I do that, you see unable to find image Nginx latest locally. Remember that I said if you don't specify the version, it's going to look for latest. So it has gone to pull that image from Docker Hub and then run the container. So if I do Docker container, first of all, if I do Docker image ls, you can see the image Nginx. If I do Docker container ls, you can see that the container. So if I go back to our and rerun, you can see we have our Nginx running. Now, so what we're going to do, let us do that practical example. I'll do that in this lecture. We're going to run a Microsoft SQL server and then access that server from from SQL Management Studio. We're going to have that server run, Microsoft server run on our local machine via a container, and then access that server from our local SQL Management Studio. So see you in the next lecture.